Hello everyone, welcome back to physics class. In the previous lecture, I derived the equation of motion. In this lecture, we will study about uniform circular motion. This is only the introductory part of this topic in your book. As such, this topic is very vast and in higher classes, you will study more about it. Before starting this topic, I want to talk a little bit about equation of motion and then we will start with this one. So, there are three equations of motion, and in lower standard, you have gone through or you have studied about distance, simple formula also. So, what is distance formula you have studied in lower classes? Distance is speed into time. Right, this is what you have studied. And now in 9th standard, I told you formula S equal to ut plus half at square. So, which formula you will use when? Either when you can use this formula, when you can use this formula. Okay. So, if you see this equation carefully, you can determine which you can use when. Here, you have one extra factor, that is acceleration. So, if body is having acceleration, you have to use equations of motion. If it is not, simple formula you can use. Now, let's see this. I will write three equations of motion. V equal to u plus at, this first one. S equal to ut plus half at square, second equation of motion. And v square equal to u square plus 2as, this is third equation motion. Okay, and this is for uniformly accelerated object. Let's put a equal to 0. Acceleration equal to 0 here. Acceleration equal to 0 means body is not accelerating. So, what will happen to first equation? So, this term will go to 0. So, you are left with v equal to u. So, here this will go to 0. So, s equal to ut. And here this will term go to 0. So, I can write v square equal to u square or same v equal to u. So, now if you see formula, distance equal to speed into time. It will come. So, this is what you have studied in lower standard. V equal to u and v equal to u. So, when there is no acceleration, you have to simply use this formula. If you have acceleration, uniform acceleration, you have to use this formula. If it is not uniform acceleration, that is totally different case that you will study later on. Okay, so let's move to now uniform circular motion. Now velocity is a vector quantity. What are vector quantities? Vector and scalar. Scalar means quantities only having magnitude, and vector, that means having magnitude and direction both. So velocity is a vector quantity. Okay, that is having both magnitude and direction. What is acceleration? Acceleration is change in velocity, right? So if velocity is changing, what you have is acceleration. So I can write here, acceleration is change in velocity. Now this velocity is having two parts. It is having magnitude also, direction also. And that simply means if I change any one of the parts, then what I should have? Acceleration. Okay. Both parts are changing, then okay, it is having, okay, that is something different case. Let's say if magnitude is changing, then also you will have acceleration. If direction is changing, then also you will have acceleration. Let's say if magnitude is constant and only direction is changing, then also body will accelerate. Okay, so if magnitude is constant, that means it is not changing, but direction is changing. Then you have this case also, acceleration is there. This you can understand by one simple example. Let's say you have a circular track. So you have 4 corners here, right? And a boy is standing over here, start running. At corners, let's say he is running with some constant speed. Okay, that means same speed he is running. But at corners, to keep pace with this speed, corners where he's changing direction, he will accelerate. Though its magnitude is constant. Yes, it is little bit tricky to understand or to imagine this. But whenever at the corners direction is changing, though it is having constant speed, this boy is said to be accelerated on this 4 corners. Let's say if I increase this corner, instead of this, I have this hexagon. Now you have 6 corners. So the boy has to accelerate at 6 points, and though he is moving with constant speed over this hexagon, but at this direction, at this point, corners, he will accelerate. If I keep on increasing points like this, let's say if I have 10 sides, so at 10 points, he will accelerate. Okay, so if I keep on increasing this corners, in the end, what I will get is a circle. Such that on a circle, if a boy is running, at each and every point he is changing direction, though he is running with constant speed. Okay, so here you will see one image also, or animation also, how this changing with how direction of velocity and acceleration vectors you can see, and how it is changing. Okay. So here in a circular motion, in each and every point, speed is constant, but direction is changing. That's why this boy is accelerating at every point. And this is center, so acceleration direction will be this, and this perpendicular. It's not exactly looking like perpendicular because this is not circle. So exactly perpendicular is your velocity direction. Okay, so for a uniform, and this type of motion is known as uniform circular motion. So what you have in uniform circular motion, if I have to write simple definition, object moving with uniform speed in circle. This defines your uniform circular motion. Okay. One more thing, uniform speed, not uniform velocity. Okay, there is big difference between uniform speed and uniform velocity. When I am saying uniform speed, that means I am only talking about magnitudes. Magnitude is not changing. Direction may change. Uniform velocity, both direction and magnitude is not changing. So in case of uniform velocity, acceleration, For case of uniform velocity, acceleration is 0 because no change in direction, no change in magnitude. In case of uniform speed, if magnitude is same, that means direction is changing, because speed is scalar quantity. So hope this definition is clear to you. Uniform circular motion means an object is traveling with uniform speed in a circular motion. Common example is electron revolving around nucleus. Okay, in an atom, in the center what you have is nucleus, and electron revolve around in circular motion, uniform circular motion. Then other example is satellites moving around Earth in uniform circular motion. So this much only part you have, and in the next lecture we will take numericals based on equation of motion. Thank you.